I'm Clover, and today we're solving a puzzle by Philip Newman. It was originally posted in GAS on April 21st, 2024. I'm not even going to begin to try to pronounce the title that Philip has chosen to give this puzzle. I will tell you that I looked it up, and apparently it is Norwegian for to swallow some camels. And the English equivalent, the closest equivalent, would be to miss the forest for the trees, I believe. So it means something like to miss the bigger picture in favor of the details. I'm not sure how the Norwegians got from that to swallowing camels. If there are any Norwegians in the comments who want to help a sister out with that, please do. I'm going to focus on the puzzle. So this is a GAS. We have normal Sudoku rules, so we're placing the digits 1 through 9, once each in each row, each column, and each heavily outlined 3x3 region. We also have some killer cages in the grid. These are these dotted outlined cages. They each have a clue in the top left corner, and that clue tells you the sum of the digits that live in that cage. And finally, we have some odd even clues. So even digits are marked with squares, or actually, to put it more technically correctly, squares indicate even digits. There's no negative constraint, so of course other digits can also be even in the grid, but we do know that all of the squares are even. And circles indicate odd digits. Again, no negative constraint. We know there are plenty of other odd digits in the grid, or in each of these cages perhaps, but we do also know that circles always have to be odd. So we're going to start by filling in, as we have so many times in this series of puzzles by Philip, these cages, which only have one way, they can each be formed. So 6 and 3 is going to be 1, 2, and 3. And because we know this is an even digit and only one of those digits is even, that's going to be our 2. 7 and 3 is 1, 2, and 4. We have to have an odd digit on the circle, so that can only be the 1. And now, because we have a 1 and 2 in these 3 cells and a 1 and 2 in these 3 cells, we have to have a 1 and 2 down here. Otherwise, we couldn't place a 1 and 2 in row 3 at all. So to complete the 8 cage, we need the third digit that makes up a total of 8 when we add it to 1 and 2. So the third digit's going to be a 5. Therefore, there's only one even digit that can go in that square. Now, if we look at the 10 cage, the smallest these could possibly be would be 4 and 5. And even if we do that, we're already at a minimum with the third digit, which could only be a 1, because that sums to 9, so that's going to have to be our 1. And that tells us which way around the 3 and the 1 go. So now if we look at this 9 cage, so the absolute biggest digit that could ever go into a 9 cage in 3 cells in Sudoku is going to be a 6, because if we place 1 and 2, the smallest 2 digits, and then we have to have a third digit, that would be 9 minus 3, or 6, would be the absolute maximum we could make that. So we know that these are all going to be 6 or less. This can't be 1, 2, 4, or 5 because those are already represented in the row. So that's going to be 3 or 6. This has to be even, so we can rule out 1, 3, and 5. We can also rule out 6 from this cell. I don't think we urgently need to do this while solving right now, but I'm going to do it anyways, because if we made this 6, these guys would have to be a 1, 2 pair, but because this cell can no longer be 1 or 2, that's right out. So that's not going to be 6. That's either going to be a 2 or a 4. And now, because we have a 2-4 pair here, we can rule out 2 and 4 from that cell. We can also rule out 6 for the same reason. And if you want some bonus points, see if you can work out why we are also able to rule out not only 3, but also 5 from this cell. I'm going to come back and do that later when I have a little more info in the rest of the grid. Let's look at the bottom of the grid. 24 and 3 is 7, 8, and 9. The only even digit is 8. 23 and 3 is 6, 8, and 9. The only odd digit there is 9. And we have to have now an 8 and a 9 in this 22 cage, so this is 5, 8, and 9. We know which way the 5 goes because of this 5 we placed up here earlier. This 20 cage, the largest these could possibly be would be 6 and 5, which means we still have to go maximal for the last digit and make it a 9. Now that 5 makes this a 1 and makes this a 5. These columns are now the most restricted part of the puzzle, so let's pencil in some of what we have here. So now, what do we still need in this column? We still need a 2, a 6, a 7, and an 8. The 8 can't go in those cells. This can't be the 6, that can't be the 7. So the 8's got to go in one of these. This is the next thing that I noticed while solving. There are other ways to progress here, but this is what jumped out at me. I noticed if I place the 8 here, that does barely work with this 11 cage. 8 plus 1 plus 2 is only 11, and that is okay at this point. However, I've already used a 1 in the region, so the smallest I could ever make this would be maybe 8, 2, and 3 if it did have an 8 in it. And 8 plus 2 plus 3 is already 13, much bigger than 11, can't do that. So the 8 definitely goes right here. And this is a 2, 6, or 7. In fact, I further noticed from there, this can't be a 7 either, because if that's a 7, then this again is a minimum of 2 and 3. 2, 3, and 7 is already 12. That's definitely not 11, so that's out. So really the only place we could put a 7 is there. Let's do something similar over here. So we need 2, 3, 4, and 8. The 2 can't go there, the 3 can't go there. We need a 2 in one of these two cells. If it went here, the 19 would have to be 2 plus 17, which is 2, 8, and 9, which is impossible given what we have so far. So the 2 definitely goes there. If that was a 3, this would be 3, 7, and 9 to make 19, which is also impossible. So we know that's a 4 or an 8, and that's where our 3 is going to live. Now the 21 cage, that's going to be kind of the counterpart of our 9 cage. So these all have to be at least 4. The smallest digit you can ever put in a 21 cage in 3 cells is going to be a 4 to make a total 4 plus 8 plus 9 is 21. So then that's 4, 5, 6, 7, 8, 9. Let's rule some options out. So this row already has 5, 6, 8, and 9. So that's either 4 or 7. This can't be odd, so we can rule out 5, 7, and 9. And now this can't be 4, because if that was 4, this would be 7, that would be 11, and then this cell would have to have a minimum of 10, which is impossible. So that's either 6 or 8, and we now have this 6, 8 pair. Ruling out 6 and 8 here. This also cannot be a 4, because if it was, we'd be looking at like 4, 7, 8 there. All right, so now let's take a more critical look at these 21 and 9 cages. I'm not actually entirely sure whether we have to do this to continue with this puzzle at this point, or if there's some way we can kind of back into this, but I'm going to walk through assuming that we're going to approach it like this. So how are we going to do that? Well, what I notice is that 9 almost always has a 1 in it, and 21 almost always has a 9 in it. So what I'm curious about is it actually possible, for instance, for this 9 cage to be the particular case where there's no 1, or can I make an argument that there has to be a 1 in the cage? Well, if there's no 1, there's only one way you can do that. It would be 2 plus 3 plus 4. It would be minimal, except that it wouldn't have a 1 in it. And there are a couple of different reasons why that breaks, actually. So first of all, there's only one cell in here where we could have a 2 or a 4, so we'd have to put both 2 and 4 into that cell, row 4, column 6. That's impossible. Second of all, even if we could somehow make this 2, 3, 4, then what would we put in this cell, row 2, column 6? That would break. We'd have nothing that we could fill it with. So we know this is not the 2, 3, 4 case, so we know it has a 1. The symmetrical argument applies to tell us the 21 cage has to have a 9 in it. Now, if this is a 1, what are these two? They sum to 8, so they're not 4 plus anything, they're 2 plus 6. And if this is a 9, then what are these two? They sum to 12, so it's not 6 plus anything, it is 8 plus 4. So where do we head next? So we need to place a 1 in this region. It can't go in any cells that are seen by these two 1s, so it goes here. We need to place a 9 in this region. 9 sees all these cells, so the 9 has to go there. Up here, we still need to place a 3, a 5, a 7, and an 8. 8 can't go in those cells, 5 can't go in those cells. We have an 8 here, which gives us a 6 and an 8, a 2 here, which gives us a 4 and a 2. This is 3, 5, or 7. And these are also 3, 5, or 7. That's not a 7, that's not a 5. Now, in this region, we need a 2, a 3, a 5, and a 7, and that can't be a 5. Now let's focus on these regions, region 1 and region 9. Those are getting pretty restricted. So those are going to contain the large digits, because we have 1, 2, 3, 4, 5, and then the small digits, respectively, 1, 2, 3, 4. So that is a 4, which rules out 4 from here. The 2 here rules out 2 from there. And we know that we have to have a 1 in these two cells because there's no 1 there and nowhere else to put a 1 in the row, so we can rule 1 out here. In fact, where do we put a 1 in row 8? We can't put it there or there. We can't put it in column 1 because there's a 1 already, so there's where our 1 is going to go. Now, do we get to do something similar up here? Well, this can't have a 6. It does have to have a 9 because the only positions for 9 in this row are in these two cells, so 9 goes in one of those. So 9 goes in one of those, so it goes there because there's a 9 in this column already. Now what? 8 can't go there because there's 8 in the column. I think I'm going to have to work now with this 11 cage and this 19 cage. I've been avoiding them because those totals are pretty unrestricted in general, but I think it's time. So we do know there's no 1 in the 11 cage, right? So the smallest digit we could ever put in it would be a 2. In fact, it has to have a 2 in it, because if it had no digits that were equal to 1 or 2, 3 plus 4 plus 5 is already 12, and that's too big to make a total of 11, so it has to have a 2. 2 is not there because that digit's odd. 2 is not here because there's a 2 already in column 2, so the 2 is going to go there. That makes this a 6. So now that that's a 2, these two have to sum to 9, right? So how do we make those sum to 9? They can't be 1 and 8. They can't be 2 and 7. They could be 3 and 6. They could also be 4 and 5. But if they were 4 and 5, they'd have to go this way around because of the odd circle. And that breaks here because we would now have 2 5s in this column. So this is 3 and 6 in that order, which resolves this. And resolves a lot of what's going on up here too. Let's do some Sudoku to finish this up before we approach the 19 cage. So this will now be an 8. This will be a 7 and a 6. And this is not a 3. And these cells are 2, 3, and 4, with that not being a 2. Those aren't 3s, so that's our 3. That makes this a 5, 7, 3. Perfect, okay. That's not a 2, so that makes this a 1 and a 2. Awesome, so now let's look at this 19 cage. So we have an 8 in it. That leaves us with a total of 11 to form. So how do we do that? Can't be 2 and 9, can't be 3 and 8. Could it be 4 and 7? Sure, it would be 7 there, 4 there. Could it be 5 and 6? No, because the 5, being the only remaining odd digit, would have to go there, and again, we'd have 2 5s in the column. So it's 4 and 7. And that resolves both the 3 4 pair and the 6 7 pair. So now what's remaining in this region? 1 3 5 and 6. And that's now a 1 and a 3, a 5 and a 6. This is not a 7. We can finish this column, in fact, because the 5 makes that a 3. And now our last digit in this row is a 4. Our last 2 digits here are 5 and 6. We need a 5 and a 9 here. And we need a 4 and a 7 to finish the puzzle. By the way, you probably noticed this pop up, SudokuCon 2025 survey. Even if you are not totally sure or not at all sure that you're going to be able to join us at SudokuCon, do fill that out. We are heavily involved with the planning process. It's not a gas event, but we are helping out with it. We are very, very, very new con planners, and any information that you could give us about what kinds of things you might want to do or see or listen to at an in-person Sudoku meetup would be super helpful to us. So please do, next time you solve a puzzle, maybe this puzzle, click that link, check it out. We really appreciate that. All right, guys, thank you for watching, and I hope you have a fantastic rest of your day.